Hi, my name is Dr. K, and I'll be teaching Physics 1401 College Physics 1 this fall at Temple College. So during the first week of class, you will have a math test. I want to check your math skills because in physics, math is extremely important. So this is a math test that I prepared for you guys. There are around 15 problems. This is a practice test, okay? There are around 15 problems, and I'm going to solve those problems, and you can check them out and then get prepared for the actual math test. Okay, so without any delay, let's go ahead and start solving the first problem. So as you can see, it says V is equal to U plus AT. These are all variables. Solve for A. So what do we mean by solving for A? We just need to have A on one side of the equation, right? Right now, it's V on one side, but we just need to have A on one side, and then we say that the equation is solved for A. Here, in this original form, the equation is solved for V. So I'm going to first write down the same equation, V equals U plus AT. And then you can see this U, the first term on the right-hand side. It's by itself. So I'm going to take it to the other side. Okay. So how do I do that? I need to subtract that. Okay. So I'm going to subtract U on this side. But since it's an equation, I need to do the identical operation on the other side. So I'm going to subtract U on the other side as well. And then you can see this U and this U cancels out on the right-hand side. So I will have V minus U equals AT. And my objective is to solve for A. Now there's a T, right? On the right-hand side, you see it's A times T. So I want to remove T, I need to divide, right? Because the inverse operation of multiplication is division. That's why I'm dividing the right-hand side by T. And then I need to do the same operation on the left-hand side. And now can you see on the right-hand side, T in the numerator and T in the denominator cancels out? Okay, so then I have A on one side. So now I have my solution. A is equal to V minus U over T. So that's the answer for the first question. So you will get some problems like this where I'll give you an algebraic expression, an equation. You have to solve for one quantity. So this is another one that we can check out. So that's number 2. T is equal to 2 pi. 2 pi is a constant. Square root r cubed divided by gm. So that's the entire equation. Solve for r. Solve for r. So that means we need to have this r on one side by itself. Just r. Not r cubed, not square root of r, not r squared. It's just r. So how do we do that? The first thing is that, can you see there's a square root? All these square root stuff are complicated. So the first thing that we should do is that we have to remove the square root. How do we do that? We can take the square of a square root, and then that square root goes away. So that's my plan. I'm trying to remove the square root. But can you see there's 2 pi that kinds of comes in the way? So I'm going to move that 2 pi to the other side. Because since it's a multiplication, 2 pi times square root, I'm going to divide 2 pi on both sides. Okay, so that's my plan. So I'm again just going to write down the equation. So before you tackle a problem like this, you need to have a mental picture, like a strategy, how you're going to go in solving the problem. And that's going to be important. So I'm going to just write down the same equation. Okay. And then I'm going to divide both sides by 2 pi. Now look, this 2 pi cancels out. So I have t over 2 pi equals square root r cubed divided by gm. Now my objective is to remove the square root. What should I do? I need to take the square on that side. I'm just going to square that. But it's an equation, so I need to do the same operation on the other side. Okay, now I'll have t squared over, I'm going to distribute the square to the denominator, so 2 pi squared, which is 4 pi squared. 2 pi entire thing squared, okay? So then 4 pi squared equals, on the other side, I'll have r cubed. Now the square root goes away over GA. Okay, now look, I'm getting closer to isolating r. I have a gm, right? So I don't need that. I have a gm in the denominator. I need to get rid of that. I'm going to multiply the entire equation by gm. Gm, it's like two quantities, g times m, right? It's like xy, gm. But as a unit, I'm just multiplying the entire thing by gm, entire equation by gm, and then it cancels out. Okay, so that's how I remove gm. Now, gm on the other side, it's not going to cancel out, right? Because there's no g or m term other than that term that I multiplied. So don't just go ahead and cancel that term on the left-hand side. And then I'm going to move my solution. So I'll have like, I'm going to rearrange these solution. So t squared, 4 pi squared gm is equal to r cubed. Look, I have r cubed on one side. So how can I get r? If I have r cubed, how can I get r? I need to take the cubic root. I need to take the cubic root. Okay, so I'm going to do that. The cubic root can also be written in this way. And then I need to do the same operation on the other side. So you have a cube, and then you take the cubic root. What's the answer? It's just that value. So here I'll have just r. And on the other side, t squared gm over 4 pi squared, the cubic root. There's another way, if you like, you can write it in this way. So I'm just going to like move my answer over here. There's another way. Cubic root can also be written in this way. So r is equal to cubic root. You can write it in this way. Okay, so that's going to be your final answer, where I have solved this original equation. So that's the original equation. That's the original equation. Using that original equation, I have solved that for r. And this is how you do it. So you should know these things, because in physics, sometimes I can ask you, okay, solve for r and then substitute numbers and get a value. So you need to do this. So this is like literal equation, manipulation of literal equation, basic algebra, okay? You use the main operations, addition, subtraction, division, multiplication, taking the square, taking the exponent, logarithms, those sort of operations. Okay, so let's go to the problem, the next problem, problem number 3. I have a simple linear equation in x and then solve for x. Okay, this should be very straightforward. You can see there are parentheses. So I'm going to distribute the 3 inside the parentheses and 2 inside that parenthesis. Okay, so 2x. That's the first term on the left-hand side. The second term, there's a 3, and I'm going to distribute that inside the parentheses. Minus 3x and plus 33 equals, on the other side of the equation, there's 2 times like the parentheses. So I'm going to distribute the 2, 30x plus 2x. And then I'm gonna put the constants on one side. Okay, I'm gonna keep the constants on one side and take the x terms to the other side. So here, can you see I have a minus x plus 33, and on the right hand side I have 32x, 32x. So I can take this minus x to the other side, right? You know, put a plus 6, and then also here put a plus 6. So then this minus x and plus x cancels out. I have 33 equals 32x plus x is 33x. Okay, and then divide by 33. Both sides divide by 33. And this is just 1. Okay, so our answer when we solve this equation, it's a linear equation in x. When we solve it for x, the answer would be just 1. So again, like simple equations like this, you should know how to solve this, because in physics, you will have a word problem. You will have to convert that word problem to an algebraic expression or an equation, and then solve that equation. So that's how we move. Like you have the word problem, it talks about the real situation, and then we convert that into a mathematical equation, a model, and then we solve that. That's how we do that. Do physics, like at least at this level. Okay, so number 4, it's like substitution. So you have these numbers. These are called scientific notations. So certain numbers can be expressed in scientific notations, especially if that number is very, very small or very, very large. In physics, we deal with such numbers which are very large and very small. So here I'm asking you to substitute the numbers, solve, and get an answer. Okay, so let's go ahead and do that. A is equal to square root, and then I'm going to directly substitute for x squared, z, and y. So x squared, first look what I'm going to do. I'm just going to write down that number in its scientific format. And then look, it's x squared, right? So I'm going to square that variable, that number, times, you don't need to put the multiplication, but I'm going to just put it. It's not a big deal. Even sometimes you can put the dot. That's also fine. And then z is 1 over 3 times 10 to the power minus 18. Okay. And then the entire thing divided by y, which is 3 times 10 to the power 5. Okay. And then let's go ahead and simplify. Again, I'm going to simplify the numbers first. So remember, there's 6, that's squared, right? So 36 times, and then 10 to the power minus 3 squared. So that's going to be 10 to the power minus 10 to the power minus 3 squared means 10 to the power minus 6. And then I have 1/3, 10 to the power minus 18. And in the denominator, that's that y value. 3 times 10 to the power 5. That's a positive exponent. So then A, 36 times 1 over 3. So that's going to be 12. And 12 divided by 3. You should like do this like mentally. Like basically like just look at all the numbers and you should be able to manipulate, like multiply, divide, all that. So 36 times 1 over 3 is like 12. Then 12 divided by 3, that's a 4. So I'm going to have a 4 there. And then I'm going to look at the 10 to the power terms, right? So 10 to the power, like in the numerator, can you see there's a minus 6, minus 18. Okay, and then look at that 5. 10 to the power 5, that exponent is positive, but it's in the denominator. So when I take it to the numerator, that exponent changes sign. So I'll have a minus 5. Okay, so then I'll have square root 4 times, look, that's 24, and 5, 29, 10 to the power minus 29. 10 to the power minus 29. So we are almost there with the answer. So A, I'm going to write down A. Now, we cannot take the square root of like kind of an odd exponent. So I'm going to like kind of like include another 10 term and then make it like an even exponent. Okay, so this is what I'm going to do there. So square root 40, meaning like I multiplied by 10. I multiplied this 4 by a 10, then I need to divide it by 10. Okay, and then that division of 10 becomes like an exponent, 10 to the power minus 30. Is that clear what I did here? Like 4 times 10 to the power minus 29. Look, 40 times 10 to the power minus 30. So what I did was that inside the square root, I multiplied by 10, that expression, and divided it by 10. Okay, that's what I did. And then I can take the square root. So square root of 40 times square root of negative 30 is 10 to the power negative 15. 10 to the power negative 15. Now we can find the square root of 40. So let me show you the calculator. So let's see square root. So 40. Yeah, it's this one. Yeah, can you see square root of 40 is 6.32. It's 6.32. So then the answer is 6.32 times 10 to the power minus 50. And that's the final answer for A for those substituted values. So you can see like we usually like in physics, we get a number, that's our objective or numerical value. And the process is a little bit complicated. So that's why I'm giving this practice test so that you guys can practice these things and come prepared for the actual math test. Hopefully, I'll be able to give it during the first week of class. Our class is going to start on August 19th. I'm recording this on August 9th. Okay, so let's look at the fifth problem. I have 15 problems, so 10 more to go. Well, 11 more to go. So use quadratic formula to solve for x. So actually, like, I'll write down the quadratic formula. So just for your information, info. So if you have a quadratic equation like ax squared plus bx plus c equals 0, then the solutions or the roots of this equation x can be given by something called the quadratic formula minus b plus or minus square root b squared minus 4ac divided by 2 times a. So that's the quadratic formula. Now during the test, don't worry about the equations. I'll give you the main equations that you will need to solve these types of problems. You can ask me during the test, and then I'll use the whiteboard and write down any equations that you need. I don't expect you to memorize all the equations, but certain things you need to memorize, you need to have an understanding. But again, if you can't remember, just tell me. I'll write the corresponding equation on the whiteboard, and then you can solve the problem. Now, this is the quadratic formula. So I'm asking use quadratic formula to solve x. But I realize that there's a much more easier way to solve this. You can actually factor. You can factorize and get the answer. So we will use that method, factorization, but totally fine like to use the quadratic formula or factorization or whatever the method that you feel like is much more easy. So let's simplify this. You can see there are constant terms, x terms and x squared terms. So I'm going to basically like group similar terms. So I see an x squared term, I'm going to take that to the other side. So mentally you can do that. So minus 5 when it goes to the other side, that's going to be plus 5. So I'll have like, 2x squared. Okay. And then I'm going to take this 25 to the other side. So when I take 25 to the other side, that's going to be a negative 25. And then I have a plus 8x. So that's going to be a negative 17x, negative 17x. And then this 1, it goes to the other side, 9 minus 1. So 9 minus 1, that's going to be an 8. That's going to be a plus 8. So that's our simplified version of the quadratic equation. So now at this point, you can use the quadratic formula, or I think it's much more easier to use factorization. So this is what I'm going to do in terms of factorization, 2x squared. Look at that minus 17. I can break it down like this, minus 16x, and then minus x plus 8 equals 0. Okay, I can do it like that. So now look, I can factorize, like I can look at these two terms and then take a factor of 2x out. It's common. So then here I'll have x minus 8. Okay, and then looking at these two, again I can factorize a minus 1. Okay, minus 1 x minus 8 equals 0. Now can you see x minus 8 is common. X minus 8 is common. So what I can do is that I can factor out an x minus 8 in this case. And then I will have the remainder is 2x minus 1 equals 0. So that's what I mean by factorization. So now the solutions or the roots are very clear to you. This equation becomes 0 when x equals 8, or when 2x minus 1 equals 0. So I'll basically write it like more clearly, like here. I know you will understand it, but I'll break it down like the equation becomes 0 when x minus 8 equals 0, or 2x minus 1 equals 0. Okay, so that means x is equal to 8, or x is equal to 1/2. So those are our solutions. The value for x, 0.5 or 1/2, or x equals 8. So that's how you do something like that. Remember, if you have a quadratic equation, try factorization. Sometimes, it's very clear you can use factorization. If that does not work, use the quadratic formula. Okay, so let's look at number 6 problem. So these are simultaneous equations. You will see solving simultaneous equations. So that means you should remember the method of elimination and method of substitution. So here I have two equations, t minus m1g equals m1a, and then another equation m2g. The ones and the twos are subscripts, okay? M2g minus t equals m2a. Solve for a and t. So using these two equations, I need to get an expression for a and get an expression for t. So first I'm going to label them like equation number 1 and equation number 2. And I'm going to first solve for a. Solve for a. So now if you look at equation 1 and 2, I think it's clear that there's a t in equation 1, and then there's a minus t in equation number 2. So what we can do here is that we can use the method of elimination. I'm going to add the two equations. If I add the two equations, you will see that t and minus t, they will cancel out. Okay, so then I can directly solve for a. So that's my plan. So that means, like, when you look at the problem, when you look at the two equations, it should be clear to you, okay, I can get one of the unknowns by using method of elimination or method of substitution. So that should be very clear when you look at the problem on the first attempt. So I'm going to like add the two, 1 plus 2. Okay, so then look what's going to happen. T minus m1g plus m2g minus t is equal to m1a plus m2a. Okay, and then t and minus t will cancel out. These two will cancel out. And then look what happens. I'll have M2G minus M1G is equal to, can you see there's a common term, A. I'm going to factor out that A times M1 plus M2. And then look, I can even factor out a G here. Okay, M2G, well, I'll factor out the G. So I'll factor out the G, M2 minus M1, factor out in the G equals A, M1 plus M2. And then I told you we need to solve for A, so I'm going to divide this side by M1 plus M2. And then I'm going to do the same thing here because it's an equation, M1 plus M2. And then you can see these two cancels out. And then we have our answer. A is equal to M2 minus M1 G over M1 plus M2. Okay, so that's one of the answers, A. A given in terms of M1, M2, and G. Okay, that's what we are asking. You can see there are no numbers. In some cases, you will have this. You won't have any numbers. So then you have literal equations and you have to simplify that. I know sometimes you are very familiar with numbers, but in physics, in certain cases, you will have to get used to this. Now I can substitute this A value in one of those equations, the original equations that we came across. Can you see I labeled 1 and 2? You can go ahead and substitute A in one of these equations and solve for T. I'm going to use equation number 1. Okay, from 1, T minus M1G equals M1. Now for A, I'm going to put this entire thing. M2 minus M1 times G divided by M1 plus M2. And then I have to simplify. T, I'm solving for T, so I'm going to take that M1G term to the other side. So it will become plus M1G. And then I'm going to distribute, right? M1, then G, I'm going to distribute in the numerator. This is a plus sign, right? Because that's plus, right? M1, there's a plus there. So plus M1, M2, G minus M1 squared G, and the entire thing, remember there's a denominator here. Denominator is M1 plus M2. So I did it in the first attempt. So just keep that in mind. You have to do it like that because we need to this is just math. Because that's why I told you, you really need to know your math in order to succeed in physics. Now, look, we are not done yet. We can further simplify this. I can have a common denominator, right? I can have a common denominator, which is going to be M1 plus M2, and further simplify this. So when I have a common denominator, I need to multiply the first term by M1 plus M2. So I'll have M1G multiplied by M1 plus M2. And then I have the rest, plus M1, M2, G minus M1 squared G. Okay, and then we are almost there. So T, now I'm going to distribute that M1G. I'll have M1 squared G plus M1, M2, G. And then I have another M1, M2, G minus M1 squared G. And then I have a common denominator, which is M1 plus M2. Okay, now can you see in the numerator, the first term and the last term, they cancel out. Look, these two cancels out. And then look at the second and the third term, they are identical. So it's like x plus x, 2x, right? So I can write this as 2m1 m2g divided by m1 plus m2. So that's the final answer. So I'll squeeze the final answer for t. So t is equal to 2 times, right? Because these two are the same. They are the same. So 2 times m1 m2g divided by m1 plus m2. And that's the expression for t. So we got the expression for A and we got the expression for T and we are done. So you can see there are no numbers. It's basic algebra. You need to know how to do this because I will give you a similar problem for the math test. So you need to practice these things. Okay, so we are done with that problem and then go to number 7. Number 7 is simple. Find the slope. I think you guys know what the slope is. Slope, simply stated, rise over run, or in other words, rise means like a vertical change. So that's our y. So change in y. Remember that delta sign, that's like that symbol, that's the delta symbol. Delta. So if you see this, that means it's talking about a change. Change in x, change in y, change in mass, change in time, change in speed. You will come across this delta awful lot in this, in this course. So that tells us there's a change. So keep that in mind. Okay, so then run is the horizontal change or delta x. Okay. So I have you are given like two coordinates like x1 y1 x2 y2. Find the slope. So for the first one, slope, I'm going to look at the y change. So 8 minus 2, and then I'm going to divide that by the x change. Remember the first coordinate, like if you have a coordinate, the first number gives us the x value and the second number gives us the y value. Okay, so I'm going to call this like, let's say x2 y2, and then here that's going to be x1 and that's going to be y1. And as you know, this change can be written as y2 minus y1 divided by x2 minus x1. Okay, so you should know these things, basic stuff. That's why I got 8 minus 2, and then I can have 15 minus 5. So then 6 over 10, we can further simplify that, 0.6, like you can write it as a decimal, 0.6. Now the next one, and then you can see that's a positive slope. So this is a positive slope. The next one, it's in the other way. So that means as x goes, x increases, y decreases. In graph A, when x increases, y increases, meaning you have a positive slope. In graph B, when x increases, y decreases, meaning you will get a negative slope. So let's do that. So slope, change in y over change in x. So I have 6 minus 26 divided by 8 minus 2. 8 minus 2. So 6 minus 26, so that's going to be a minus 20 divided by a 6. Okay, so that's going to give us a negative slope. So 20 minus 6, let's figure that out. So 20 divided by 6, divided by 6. So that's 3.33. So we'll have 3.33, and that's a negative slope. Okay, so that's a negative slope. So that's like the negative symbol. Okay, that's how I do that. I mean, if it says positive, like plus VE meaning positive, negative symbol VE meaning negative. It's kind of a short way of, like a quick way of writing the positive and the negativeness. So I hope this is clear. Like you need to know how to find the slope. Remember, if you have a flat line, the slope is 0. If you have a line like that, then a negative slope. If you have a line like that, that's a positive slope. Okay, so let's go to the, we are almost halfway. Let's go to the next one, basic trigonometry. So find x and y. So that's like our hypotenuse, right? You should remember this basic stuff. That's the hypotenuse. Angle is 30. Opposite to that, you have x, so that's our opposite side. And then the other one is adjacent. Okay, so find x. So that means like the opposite, right? So so that means always it'll be related to sine. So I'll write down sine. If it's opposite, then it's sine. So sine of the angle theta, sine is defined as opposite over hypotenuse. So I'll simply write opposite over hypotenuse. And then I'm going to substitute what is opposite, that's x, and hypotenuse is 12. So then I have sine 30 equals x over 12. I'm going to multiply both sides by 12. Cancels out. So x is going to be 12 sine 30 degrees. Sine 30 degrees is 1/2, 0.5. I know that it's 0.5. So then you can just go ahead and substitute 12 times 0.5, which is 6.0, something like that. Yeah. So x is 6.0. Then y, look, y is the adjacent. So always with adjacent, it's going to be cosine. So cosine 30 is equal to adjacent over the hypotenuse. And the adjacent is y over hypotenuse is 12. So you can see just like previous one for x, we can get y equals 12 cosine 30 degrees. Now I can't remember the value for cosine 30 degrees. So let's go ahead and use the calculator to figure that out. Cosine, so trigonometry, I think there's an odd way of doing it. You put the angle first 30, and then this is like the calculator that comes with Windows 10. Okay. Then trigonometry, use the right function cosine. Look, cosine 30, 0.866. And these values are in degrees, okay? These are degrees, not radians. These are all degrees. And then I need to multiply that value by 12 because that's our hypotenuse, right? 12 cosine 30. You can see here. Let me see whether, yeah, 12 cosine 30. So I need to multiply this by 12. And then 10.39. I'll write 10.4 as the answer. Okay, 10.4, that's the answer for question number 8, part A. Question number 8, part B, again, there's a right angle triangle, so we need x and y. So let's go ahead and simplify. So here, y hypotenuse, it's not given. Look, angle is 60, opposite to that, that's 8. So that's our opposite side. And then x is the remaining, which is the adjacent side. Okay, so remember, sometimes your hypotenuse will be unknown, your opposite side will be unknown, your adjacent side will be unknown. It depends on the problem. But if you know how to define the trigonometric functions, you should be able to do these problems. Okay, I'm going to first look at let's say the hypotenuse. I'm trying to find the hypotenuse. So I'm going to use the sine, okay, sine 60, okay, to find y the hypotenuse. So sine 60 is opposite over hypotenuse. I'm going to directly write the opposite side now. It's 8 over hypotenuse is y. So we need to solve for y. So let's do that here. Y is equal to 8 divided by sorry, it's not cosine, it's sine. It's sine 60. So sine 60. Okay. So let's do that using the calculator. It has this weird like way of doing it, but let's try to do that. So I'm going to clear everything. 8. Okay, let's see, divide it by, I need to put sine 60, right? So 60 first, and then the sine function. Okay, yeah. So then I should be able to hit clear, yeah. Sorry, not clear, equal sign, and then I get the answer, right? So 9 point, let's say 24, up to 3 sig figs or 2 decimal places. The answer is 9.24, right? That's what we got here, 9.24. Okay, so that's how you get your y value. And then let's look at the x value. So x is like the adjacent, 8 is the opposite. So I'm tempted to use tangent. You can always use like cosine, that's also fine. But I'm going to go with the tangent this time because we didn't use that earlier. So tangent 60 is what? How do you define tangent function? Just think. Opposite over adjacent. Opposite over adjacent. And then opposite is 8. Adjacent is what I'm trying to find out. So that's x. So I'm going to solve for x. So again, this is where like you need to know how to, if you get like literal equations, how to solve for one variable. This is another place you will use that. So when I solve for x, the answer is going to be 8 over tangent 60. Okay, so let's do that again using that calculator. I'm going to clear 8, divide that by 60, that's the degree, and then the tangent. Okay, I'm going to hit equal sign. 4.62 up to 3 sig figs or 2 decimal places. 4.62. So that's our x value. So x value is 4.62. Okay, guys, so that's how you do get x and y for 8 part B. Now let's go to 9. So again, we have a right angle triangle. Here we need to find the hypotenuse, right? So that's the hypotenuse. That's the opposite. And this is the adjacent. I need to find the hypotenuse. So look, the other two sides are given. So I can use Pythagorean theorem. So what's Pythagorean theorem? R squared is equal to, in this case, 3 squared plus 4 squared, which is 25. Okay, so then R, you are going to take the square root. Mathematically, you will get plus or minus. But since this is a physical quantity like a length, it's not negative. So we'll just use the positive value, square root of 25, which is 5. So the R value is going to be 5. Okay, it's that simple. And then how do we get theta? How do we get theta? Again, you can use the main trigonometric function, sine, cosine, tangent, to find the angle. Since the opposite and the adjacent was originally given in this problem, I'm going to use tangent. Okay, I see that tangent theta is equal to opposite over adjacent. And in this case, opposite is 3, adjacent is 4. So I have 0.75, right? And then theta, I need to solve for theta. So I'm going to take the inverse trigonometric function of tangent on both sides. So then I'll have theta equals inverse tangent 0.75. And then let's try to get a numerical value. Again, let's use that calculator. So clear up 0.75. Let's see, 0.75. I'm going to hit trigonometry, and then second, that's how I go to the inverse functions, then inverse. Okay, so it takes the answer. So 36.9869, I'll say 36.9 for 3 sig figs with 1 decimal place, 36.9. Okay, so that's a different one. Sorry, that's not the right one because I have divided that by 1.75. So that's not right. Yeah. So remember, we just need. So let me see whether I can go back. Yeah. So anyways, like I'll do that again. 0.75. Go here. Second function inverse, and then you get the answer. Okay, 36. So 36.9 degrees is the answer. 36.9 degrees because look, inverse tangent 0.75 is the same function. Okay, so that's how you do that. Okay, 9. So let's go to the 10th one. We have like 6 more to go. 10th one, okay, cancel. 10th one, there are 2 parts, A and B. So these are like exponents and logarithms. So solve for t. So can you see t appears as an exponent? So I need to first isolate that exponent term. So I'm going to divide everything by a. So just like that. And then this a cancels out. So I'll have e to the power minus bt is equal to yt divided by a. And then I'm going to take logarithms on both sides to get rid of the exponent, right? It's like the inverse function, plus, minus, multiplication, division. So like that, logarithms, exponents. That's how those are the complementary functions, like inverse functions. So when I take logarithms on both sides, I'll write it down, natural logarithms, okay? And then here, natural logarithm of yt as a function of t divided by a. And then on the left-hand side, that exponent negates itself with the logarithm. So I'll have minus bt equals, so that's a little bit unclear, right? So I'll write that again. So minus bt is equal to ln yt divided by a. And then I'm going to solve for t, that's the objective, minus 1 over b ln yt divided by a. If you like, you can put the negative sign inside that logarithm in one, and then the numerator and the denominator will shift, but I'll keep it like this. I'll keep it like that. But remember that negative sign can be, you can put it inside the logarithm, and then the numerator and the denominator will flip. I'm not going to do that, but you can do it if you want. Okay, so this one solve for x. I have a logarithmic function, so the inverse operation is the exponent. So I'm going to take the exponent on both sides. Okay, so ln absolute value of x, and then e to the power 2d. E to the power ln x is simply x, e to the power 2d, and that's the answer. It's very straightforward. Okay, now let's go to problem number 11. So this is a little tricky one. My plan is to again give you something like this. So I have a function of b, fb equals 1/3 ab squared, where a is a constant. It's not going to change, but b can change. That's why, can you see b, the function's variable is b. The question is, if b is tripled, what is the new value, say f new, in terms of f? Okay, so let's say that f new is 1/3 times a, and then look, b value is tripled 3 times. So 3b And this is where students make the mistake. They need to put the square, they need to take the exponent of the entire thing, 3b, not just b squared. So sometimes I have seen students doing this. That's wrong. Don't do it, okay? You have to put parentheses around the entire term 3b and then take the square. That's the right way of doing it. I'm going to test you, especially this type of a problem during the math test. So now you can kind of distribute that exponent, and then I'll have 1/3 a. 3 squared is 9, and then b squared. And then rearrange, if you pull out a 9, you'll have 1/3 a b squared. So what is this 1/3 ab squared? If you look at the original one, that's fb. That's fb. So our f new value, so this is simply f, the function f. So our new value for the function when b is tripled is 9 times the original function. 9 times the original function. So that's how you kind of express it. If you triple b according to this, the new function will be 9 times the original function. Okay, let's do a similar one, but here it's in the denominator, not in the numerator. So fr, again, a constant a divided by r squared. Now r is halved. R is halved, then what is the new f value? So f new, a remains the same. You can pause the video and you can try it out. R becomes halved. So r divided by 2. But remember the parentheses, like you need to put the parentheses around the entire term and then take the square. Okay, so then you can simplify this r squared divided by like 2 squared. 2 squared is a 4, and that goes to the numerator. So 4 times a divided by r squared. What is a over r squared? That's f. So then the answer is 4 times f. 4 times the original value. If we have that r value, f new is going to be 4 times the original f value. That's how you do it. And then this is very important. This process, understanding this process is very important. Okay, number 13, we have, around, 3 more to go. So find the side AB. So what is AB? That's this side. In terms of D and theta. Theta is this entire angle. D is one of these sides. So this is an isosceles triangle where 2 sides are equal, D and D. So you can see AC is equal to BC, okay, equals D. So it's an isosceles triangle. And then when you draw a perpendicular line from C to AB, it intersects at point O, AB is intersected at point O, then you are going to get these like identical right angle triangles. So that means this theta is going to get bisected by that perpendicular line CO. So here you will have theta over 2 and theta over 2. And also these two lines like AO and OB are also going to be the same. Okay, so using the trigonometry, can you see that's a right angle triangle. I'll use a different color here maybe. Yeah, so can you see there's a right angle triangle here. And then it's identical to the other right angle triangle. So if you look at the right angle triangle, there's an angle and AO is the opposite side. And then we know the hypotenuse D. So here you should write clearly, like it should be clear to you, this AO side is going to be D sine theta over 2. Similarly, OB is D sine theta over 2. So then AB can be written as AO plus OB. They are the same, right? So I have D sine theta over 2 plus D sine theta over 2. So the answer for AB is 2 times D sine theta over 2. Now, don't think that you can cancel this 2 with this 2 inside the parenthesis, right? Remember that parenthesis is the angle. Theta over 2 is an angle. You can't just divide, like cancel that with a constant 2. You have to be very clear what you're dealing with. So theta over 2, that 2 is a part of an angle. But this 2 on the front, that's a number. So you have to be very careful. So that's how you get AB, okay, in terms of D and theta. Now, you might argue like it's not theta, it's sine theta over 2, but like theta, it's there, right? So sine is basically like, it's a function of the angle. So this is fine. So 2D sine theta over 2, that's the answer. Okay, number 14. Again, find theta and then x. You are given the distance x. So that's the side of a right angle triangle. So theta, that's theta. So it's like the opposite, right? You have to identify, okay, do I know the hypotenuse? Do I know the opposite side? Do I know the adjacent side? So this is the hypotenuse, 10 is the hypotenuse, and x is like the opposite, okay? But first, let's find out what is theta. Look, I have a right angle triangle. This is theta. So this is 90 degrees. So then this must be 60 degrees. It's that 60, then this is 60. That's going to be 60 degrees. If that's 60, then since this is 90, that angle is going to be 30 degrees. So from geometry, you should be able to identify that theta is equal to 30 degrees. And since that is 30 degrees, x, since it's that the opposite always goes with sine. So then you should clearly see sine 30 degrees is opposite, which is x over hypotenuse, that's 10. So x is going to be 10 times sine 30 degrees. Again, I told you sine 30 is a number very easy to understand. It's 0.5. So the answer is 10 times 0.5, which is 5, okay? So theta is equal to 30 degrees, and then our x value is equal to 5. That's how you do that, okay? All of these are very important math ideas, concepts that will be very important in physics. So that's why I'm doing this as a practice for you guys, because I have a practice test during the first week of class. Okay, so last one, 15. This is like part of a circle. Okay, so you can see AC equals BC, that's R. So it's like the radius. This is like the radius, guys. That's like the radius. Okay, so this entire thing is R, and then this entire thing is also R. The objective is find BO. So BO is this side. What's that? So we can write BO in terms of that radius, right? Can you see? BO can be written as the radius is BC minus, look at this part, that's OC. That's how we can write BO. Now, what is OC? Again, you have to use trigonometry. So if you use trigonometry, you see there's a nice right angle triangle here. Okay, hypotenuse is our radius, theta, and then I'm asking OC. This side is like the adjacent side, right? That's the opposite, adjacent, and this radius R is our hypotenuse. So from there, you can see adjacent always goes with cosine. So OC is radius times cosine theta. So simply by looking at a figure, a right angle triangle, you should know how to do this. So then BC is what? That's the radius R. OC is what? That's the adjacent of that right angle triangle. So that means hypotenuse times cosine theta. Hypotenuse is simply the radius times cosine theta. Okay, so then BO is simply R minus R cosine theta. You can factor out an R if you like. So then I'll have 1 minus cosine theta. So finally, BO is equal to R 1 minus cosine theta. Okay, so that's how you get complete the final problem. So I did 15 practice problems. Practice these problems again and again, because for the final test, for the actual test, the math test, you will see similar problems. I'm not saying identical problems, but similar problems. Okay, so you should know all these things. Okay, guys, so I'm going to post this in my YouTube channel, and I'll put the link in D2L. Please go ahead and take a look at this. And if you have questions, you should have my email in D2L, or you can just make a comment on my YouTube channel, and then I can reply to those questions. Okay, guys, see you during when the school starts. I'm excited to see you guys and teach you physics. But remember, math is super important. If you struggle with math, you need to, do something about it. Okay. Okay. See you during the class.